Good afternoon, class. Today, we are going to learn the spanning tree protocol. Before we start to learn the new things, let's have a quick review of how switch works. In this topology, we assume that computer AA wants to send data. When AA transmits the data to switch A, it forwards the data frame according to the MAC address table. If A checks the MAC address table, the destination address does not exist in the table. Switch A would broadcast this data frame, and a broadcast storm is generated when there is a physical loop in the network. Let's take a look at the diagram. If A checks the MAC address table, but the destination address does not exist in the table, switch A broadcasts this data frame. Switch B and C check the MAC address table. The destination address is unknown. B and C would broadcast the frame as well. Then, in this way, a two-way broadcasting ring is formed in the network, and the broadcast will never stop, generating a broadcast storm. A broadcast storm will eventually lead to network resource exhaustion and switch panic. So, how could we solve this problem? We use the STP spanning tree protocol. Spanning tree protocol, which logically breaks the loop, prevents the generation of broadcast storms when the line fails. The disconnected interface would be activated and restores communication, plays a role of backup line. So here comes a question. How does the STP spanning tree protocol choose which link logically needs to go down? Let's learn about the STP algorithm. Here are the steps of how STP generate a loopless topology from a loop network. Select the root bridge. Bridge is a predecessor of the switch. Because STP is developed on the basis of bridge, so we still use the term bridge in the switch network even in this day. Select the root port. Select the designated port. Let's go into the first step. How to select a root bridge. The root bridge is selected based on the ID of the bridge, which we called BID. The BID is unique, and the switch with the smallest BID value is selected between switches as a root bridge in the network. And the purpose of selecting the root bridge is to determine a tree root for the tree structure that will be generated. The BID consists of two parts: 2 bytes of the bridge priority. The default value is 32768, and 6 bytes of the bridge MAC address. Now, we are going to take the following topology diagram as an example to introduce the calculation process of STP. According to the topology, we can know that switch A has the smallest priority value and the MAC address value is also the smallest. So, the smallest BID value in the topology is switch A. It is selected as a root bridge. Next, we are going to select the root port. The root port is a port closest to the root bridge. On the non-root bridge, we select it based on 1. The least root path cost. 2. The smallest ID of the directly connected bridge. 3. The smallest directly connected bridge port ID. The root path cost is the sum of the costs of all links on the path from this bridge to the root bridge. In the topology diagram, the root path cost of port 1 on switch C is 19 plus 100, which equals to 119. The second part is a port ID. It is composed of 8 bits of port priority and 8 bits of port number. The default value of the port priority is 1 to 8. Let's look at the following example of how to select a root port. On B and C, the port closest to switch A are the root ports of B and C. Next, we are going to select designated ports. We can select one designated port on each network segment. The ports on the root bridge are all designated ports, and on the non-root bridge, we select it based on 1. The least root path cost. 2. The smaller BID value of the bridge where the port is located. 3. The smaller port ID value. Let's take a look at the example of selecting a designated port. First of all, the ports on the root bridge are all designated ports. So, the 2 ports on switch A are designated ports. On the network segment which connects switch B and switch C, the BID of B is smaller. So, the port on B is a designated port. So that all the designated ports on the 3 network segments are generated. This port on switch C is neither the root port nor the designated port. So STP blocks this port. After the calculation of STP, the final logical structure is an acyclic topology. The line between switch B and switch C is used as a backup line. That is the content of this lesson. Please finish the calculation job of STP on page 15 of the slides. The job is to find and mark the root bridge, root ports, designated ports, and the block port on this topology.